This is Professor Rogers. In this presentation, we look at how to create and interpret frequency tables in SPSS and PSPP. Frequency tables are the statistical technique used for univariate descriptive statistics when the data are categorical. Associated with the frequency distribution are two measures of central tendency, the mode and the median, though which measures can be used depend on whether the data are nominal or ordinal. This video uses as an example data collected for the 50 states and the District of Columbia. There are a total of 51 observations. Two variables will be used, reg name and educ level. Reg name contains the name of the region of the country in which the state lies. Educ level is a composite measure of educational attainment and performance for each state. It has three categories, high, medium, and low. To find the frequency command, we start with Analyze in the top menu bar, move to Descriptive Statistics in the drop-down menu, and then slide over to Frequencies. Clicking on Frequencies gives us this command dialog box in SPSS. The left box is already filled with the names of the variables in the dataset. The right box, which is empty right now, is the list of variables for which we want to create frequency tables. You can grab the sides and corners of this box with your cursor to make it larger or smaller. This ability is especially important when you cannot read the names of the variables in the left box. Expanding the box gives more space for the variable names. In the lower left-hand corner is a box labeled Display Frequency Tables. This box should be checked by default, but if it is not checked, you need to do so. PSPP has a slightly different layout for the command box, which I will show in a moment. To select a variable for analysis, click on the variable name. Then hit the toggle button, which is located in the center of the box and is here marked with the red arrow. When you are ready for output, click on OK. I have selected two variables for analysis, region name and education level. PSPP has a slightly different command box. The process for selecting a variable for analysis is the same as SPSS. However, in the lower right-hand corner, PSPP by default selects certain characteristics to be included in the analysis. These statistics are for numeric variables, not categorical ones like we are using here, and so these boxes should be unchecked. There is no display frequency tables in the lower left-hand corner, but providing a frequency table is the default setting. If you doubt whether frequency tables will be part of the output, click on the option Frequency Tables to look at the settings. When you are ready for output, click on OK. In SPSS, the first table we see is a summary of valid and missing observations for each variable in the analysis. This summary is useful if we are not familiar with our data. We see that all the data for region name is valid, and the variable education level has one missing data point. If we go back to the data view and look at the data, we would learn that the missing data point is the District of Columbia. PSPP does not provide this table in its output. The core outputs are frequency tables. Here I have laid the frequency tables for the variable region name from SPSS and PSPP side by side. Although the format of the table is slightly different, the columns are the same. Whatever I say about the SPSS output is the same for PSPP. The first column is the values of our variable. Region name has 4 values, Midwest, Northeast, South, and West. If we have a numeric variable with the values labeled, we would see the value labels. Notice that there is also a row at the bottom of the table for the total. The second column is the frequency column. This column gives the number of states associated with each region. There are 12 states in the Midwest, 9 in the Northeast, 17 in the South, and 13 in the West, which comes to a total of 51. The next column is labeled percent. It is the percent of the 51 observations associated with each row. We multiply the answer by 100 to get a percent. If we do not multiply by 100, we have what is called a probability or a proportion. How this calculation works for each region is shown here on the slide. The valid percent column used the total number of non-missing observations for the percent. In the case of region name, the percent and valid percent columns are the same. This situation does not always occur. Education level is an example where the percent and valid percent columns are not the same because data from the District of Columbia is missing. Notice that a new row has been added above the total for missing data. The one missing observation accounts for 2% of the observations, and none of the observations with a valid percent. The final column is the cumulative percent. The cumulative percent column adds together the frequencies for the current row with all previous rows, and then calculates this sum as a percent of the total. For example, let's look at Northeast. If I add together the 12 Midwest states preceding Northeast on the table, from the 9 from the Northeast, I have 21 states, or a cumulative percent of 41.2%. Note that there is no cumulative percent in the total row, because we reach the 100% of observations in the row for West. The problem with this example is that region name is a nominal variable. There is nothing wrong with changing the order of regions. The order in the output is alphabetical, but if we follow the convention set by the U.S. Census Bureau, the order of regions in a report would be Northeast, Midwest, South, and West. If I change the order of regions, all the results in this table would remain the same except for the cumulative percent. Having a statistic that changes with the order of variables makes no sense, so we do not use cumulative percents with nominal variables. However, if the data are ordinal, the cumulative percent makes sense once we establish the order in which we wish to present the variables. Nonetheless, even here we need caution. We could reverse the order of our categories, which is quite appropriate, and thereby change the values in cumulative percent. Thus, we learn from this example that we need to be very careful when we report or interpret cumulative percents. We should not use them at all with nominal data. And with ordinal data, we should make sure that we have the data in order that makes sense given our conceptual argument. There are two measures of central tendency that are used with frequency tables. By measure of central tendency, we mean a single number that can be used to summarize the distribution. These statistics are not generated by SPSS, but they can be easily found by examining the frequency table. The first measure is the mode. The mode is the category with the most observations. Modes can be used for both nominal and ordinal data, and we find them by looking at the frequency or percent columns. In the examples used in this presentation, the mode for region is South with 17 states. For education level, the mode is medium with 27 states. The median, our second measure of central tendency, is where the middle of the distribution lies, or what is often referred to as the 50th percentile. The median is found by locating where the 50th percentile is using the cumulative percent column. In the case of education level, the median is the category medium. Although the cumulative percents change if I change the order of the categories, the 50th percentile in an ordinal distribution would remain the same. This fact explains why cumulative percents are useful with ordinal data. However, remember that there is not an order to the variable region name, so this variable does not have a median. The location of the median would change based on how the region names are organized, and there is no intrinsic logic to this ordering. In this presentation, we looked at frequency tables. Frequency tables are the statistical technique used with categorical data. There are two associated measures of central tendency, the mode and the median. However, we also learned that the type of data introduces an important caveat into what parts of the output and statistics that we can use. Cumulative percents and medians can be used with ordinal data, but they cannot be used with nominal data. All other parts of the frequency table and modes can be used with both types of data.